Hi guys, and welcome to this video on graphing straight lines using intercepts. Yeah, my name's Darren, Maths Guru. Thank you so much for joining me. If you can, do me a favor and subscribe. I know it's a bit early in the video. You're like, hold on a minute, I haven't even started. I know, but I'll forget because I'm old. If you subscribe, that's just one little click of that button. But for me, it just shows me that people are actually watching, yeah? Wow, it's hard doing maths videos, but knowing that people are out there actually watching these videos really does mean a lot to me. And leave comments, guys. Let me know how you think I'm going. All right, so what are we doing today? We're building on our new series of videos on linear relationships. We're going to draw straight lines from intercept. Now, if you don't understand what an intercept is, I have a video on that. In fact, you can find it on mathsguru.com or YouTube. But intercepts are effectively where straight lines, or in fact any lines, cut through the x-axis and the y-axis, he says, labeling them in completely the wrong way. So this point here and that point there are intercepts, right? That's what we're going to learn a little bit more about today and sort of use, right? So we're going to understand that we need a minimum of 2 points to sketch a graph. Hopefully you should know that already. Know how to find the x and y intercepts from a rule of a linear graph. Again, we should be able to do that and then sketch it, right? So a lot of this is building on that previous video. All of this deals with linear relationships. Y equals x plus 2. Y equals minus 2x minus 3. These are just examples that are coming off the top of my head. I know that each of these is a straight line. Why? Because it's got a y letter, an x letter, and a number. This has a y letter, an x letter, and a number. That number doesn't always need to be there because I can actually have y equals 4x. That is still a linear relationship because it's got a y in it, it's got an x in it. If I had y equals x with a floaty 2, that is not linear. It may have a y and an x in it, but the x can't have a floaty number. If I had 3y minus 4x equals 2, is that linear? You're all going to say no. Yes, it is, because it's got a y in it and it's got an x in it. The rest of it might look different, but we'll come back to later. So everything we were doing in the previous video talks about relationships. This idea that I can take x values, put them into some sort of rule or relationship, and come out with y values. And in many cases, they give me straight lines. So here we have a relationship from a previous question, and we know that the intercept, I can read that value off because that's my y-axis intercept. Right? My graph would cross through that as 0, 2. And I know that this here is my x-axis intercept, which would have the coordinate value 1, 0. Now there is a number in maths we love, and that is the number 0. Why? Well, it's cool to draw. No, it wasn't it? It is anything times by 0 is 0. That's why we like it. So does that give me a hint to where to go with this type of work? Yes, we like the number 0. So we can find intercepts that we've already got. So if I have an equation, y equals x plus 3. What do we know about a y-axis intercept? A y-axis intercept always has an x value equal to 0. And if you don't believe me, look at all the points here. If that point, any of these points that I'm drawing on this graph here now, and I look at the coordinate values, what are the x values for every single one of those points? It is 0. And likewise, if we look the other way on the x-axis, what would we notice about every point that falls along the x-axis? It would also be 0. So that's really important. Our y-intercept has an x value of 0, and an x-intercept has a y value of 0. And actually that is the sort of stuff for this whole video, because what I'm now going to do is I'm going to write this equation out twice. I'm going to write y equals x plus 3 and y equals x plus 3. And one of those equations, I'm going to let x equal 0. And the other equation, I'm going to let y equal 0. So let x equal 0 in this one, and let's y equal 0 in that one. Now, if your algebra skills is very hot, as in very good, you'll already know what to do here because, well, y becomes 0 plus 3, which is 3. And we would have to take away 3 from both sides here to give me that x is equal to minus 3. Well, what are we going to do with that now? Well, this equation here, this working out, basically was when x was 0, it told us that y was equal to 3. We got a coordinate. Hold on a moment, we've got an intercept. And this value here, we've got x equals minus 3 when our y value was 0. And having got those two coordinates there, we can actually plot those on a set of graphs and draw a straight line. So as you can see here, oh, my little mate there, all right? What can we see? We can see that I've now plotted my 2 points. There is my x-axis intercept, there is my y-axis intercept. And the minimum number of points we need to draw a straight line is, 2. So using my ruler, I'm going to join those 2 points together. And obviously I don't have a ruler, but you guys do. Have I now got this graph correct? Sadly not, no. You should think of the axes, this little thing here, as a picture frame. Right? So those axes that I've drawn a picture frame, they're not the whole picture, they're just a little part of the picture. Your line goes on to infinity and beyond. Oh, I love blush a lot here. So you actually have to draw this graph all the way to where the axes stop. Don't draw it beyond. If you draw it beyond, sadly, that is wrong. Don't do that. Only take it to the edges. But again, you need to put on your arrows either edge. You need to put a y there. You need to put an x there. And label the equation, which, as we said there, was y was equal to x plus 3. Do that in the exam and you are, show me the mark, show me the mark, give me the marks, yeah? Absolutely fabulous. Right? If you miss any of that out, probably, or your points are wrong, you're going to lose marks. Now, as I said a moment ago, there are lots and lots of different ways of doing straight lines. But I promise you that if you put those into a graphing package, and a great one you can try is Desmos.com, and then go to calculator. If you go to Desmos.com and do a calculator and put any of those equations in, you will get straight lines. And they will have different slopes, they'll have different places where they're put. And even if you put this one here, 2x plus 3y equals 6, in Desmos, it will give you, well actually, it gives you this line here. So once again, I'm going to put my y and my x on there. And you're going to turn and say, well, why? How is it that those there are straight lines and those there are straight lines? Well, they're really the same thing written in different ways. These 4 equations here are called gradient intercept form, right? And we're going to do a video on gradients and intercepts later on. This one here is actually just called intercept form, because when we have it in the way of 2x plus 3y equals 6, it's much easier to find intercepts than it is in the other way. So, just the point of this slide here is to remind you that we can write equations for straight lines in lots of different ways. Now, when I say ax plus by equals c, what I'm really saying is that a and b can be any number, or a, b, and c can be any number too. So I could have 3x minus 2y equals 7, or 4x minus 6y equals 10, or 3x minus 2y, let's do plus 2y equals 0. All sorts of different ways, yeah? But what you notice is we've got an x, we've got a y in each of them. Now, writing it in this format makes my life so much easier to be able to do straight lines from that particular format, right? So here's an example. 3x plus 5y equals 15. We're going to use intercepts. And what do I know about my intercepts? I know that my x-axis intercept is when y is equal to 0. My y-axis intercept is when x equals 0. And you'll notice I will write that down every single time. It's training my brain to get this right. So I'm going to write down my equation twice. 3x plus 5y equals 15. And I'm going to write it again down here. 3x plus 5y equals 15. The reason I'm doing this is I'm running out of space on my PowerPoint. Right, so this one here, I'm going to let x equal 0. And this one here, I'm going to let y equal 0. So, well, hold on. Anything times 0 is 0. So in which case, if I do that, then this 3x term here is just going to get disappeared, and I'm going to get left with 5y equals 15. Well, I can solve that now using my algebra, so y becomes equal to 3. And if I now go to my next equation where I let y equals 0, well, anything times 0 is 0. So now this thing here disappears, which just leaves me with 3x equals 15, or x is equal to 5. Now, why did we do this? Because what we've now done is found two coordinates. Coordinates always have an x value followed by a y value. Well, for this one here, the x value was 0. The y value is 3. So what I'm going to do is plot that. 0, 3. There is my kiss. This one here, I have to plot my x value first, which is 5. My y value is 0. So 5, 0 puts me here. And lo and behold, just by doing those two calculations, I have got my straight line looking, oh dear, nothing like that whatsoever. So let's try that one again. He says, rotating his iPad around and using his technical drawing experience from the United Kingdom. There we go. There are my arrows and there are my arrows. And I've drawn my straight line. Thank you very much. Don't forget to write on there 3x plus 5y equals 15. Put a y there and put an x there. And yay, we've got it. Oh, fist bump. Oh, I'll just touch my microphone. That probably clicked. And again, we don't have to have it in intercept form. We can still do it this, yeah, in exactly the same way. Just write the equation down. Y equals 3x minus 6. Write it down twice. Y equals 3x minus 6. For this one here, let x equal 0. For this one here, let y equal 0. Now, again, when x equals 0, that's just going to disappear. And so y becomes minus 6 straight away. So that becomes 0 minus 6. Now I'm going to let my y equal 0. So 0 is equal to 3x minus 6. I want the x on its own. It's currently kissing the 3. Leave it alone. Get rid of the loser. Get rid of that minus 6 by adding 6 to both sides. So 6 becomes equal to 3x, or x becomes equal to 2. Now, again, that now means I have my coordinate position of 2, 0, because my x value is 2, my y value is 0. Do I have all the information I need? I absolutely do. 0, minus 6 is going to go there. And 2, 0 is going to go there. And once again, let's try and use my graphical drawing skills to do this properly. He says, knowing full well he's going to mess it up. And you would never draw your graph like this, by the way, guys. You should always keep your pencil on that page. Well, you're going to use a ruler, so there's nothing to worry about. But you should always make sure you draw a straight line in one go. Right? In the United Kingdom, I used to get very upset when people who did sketch graphs like this. It's not art. Now don't forget, we're going to try and trick you. We have told you again that normally our axes are x and y. Yes, that's our convention, but they don't have to be. In questions later on, we're going to change those to things like time and distance, for example. Right? There are so many different letters you can use, but what you need to realize is that what we're trying to find is relationships between those letters. No matter what the letters is, it's still a straight line graph. All right, so for example, as I say here, if I had d is equal to minus 2t plus 8, this t here, if you go back to the general equation of y equals some value times x plus some other value, whatever's in place of the x is the letter that goes on the axis. So there we go, the x becomes a t. In this situation, the y became a d. And now I could just put my information in there, solve it, and find my straight line. Now this is a bit of an extension for those of you who want to know how to find equations when given the intercepts. And there is a rule. So it basically says if we take the x, a letter x, and divide it by the x-axis intercept and add it to y on the y-axis intercept and put it equal to 1, we can find the equation of the line. So I'm going to do it on the here. So let me see, I've got to take a letter x and divide it by the x-axis intercept. Well, that value there is 3. Now you're going to turn around and say, do I put the coordinate? No, it's actually the x value. I should write that as an x value. Plus the y divided by the y-axis intercept. So in that situation, it's 2 is equal to 1. Now we could leave it like that, but that's not in the right form. We'd like it to be in either gradient intercept form or intercept form. So what I'm going to do is take a common denominator of both of those. I'm going to divide those both. I'm going to turn them into a common denominator of 6. So 3 to 6 is doubled. So I need to double the x, 2 times x. 2 to 6 is done 3 times. So that becomes 3y equals 1. And then I'm going to multiply both sides by 6 to give me 2x plus 3y is equal to 6. So I now know that that equation there is 2x plus 3y is equal to 6. Yeah, see what we've done there? Now again, if you want to check this, when x equals 0, 3y is equal to 6, so y equals 2. This again is an extension topic and it comes up very, very rarely, but you never know. Your teacher may throw that one in there, or you may be lucky enough to have been taught that. But that's the end of this video. Thank you very much for watching. Hopefully it has been useful. My name's Darren. Please subscribe, tell your mates, and go over to mathsguru.com. It really does, as I say, mean the world to me. And leave me a comment. Let me know how the video was. Yeah, I'm done. Thank you very much. I look forward to seeing you in another video. Stay safe and take care. Bye-bye.